we don't want delta in terms of x. So let's just maybe just restrict. So what we're going to do is the definition of the limit says near a. That's important. So that near a, that f approaches the limit L near a. So why don't we just restrict x minus a, this distance, the delta, how far a is away from x? Why don't we say that's near a and within 1 unit of a, if that makes sense? Let's see what we can get from that particular fact. Let's see, can we derive x minus 3 in those terms? So let's see, what is x minus 3? So let's say, excuse me, let's say for argument's sake, let's restrict delta to be less than 1. Okay, so now what we have is, therefore we have that x minus 3 must be less than 1. Expanding this out, this implies that minus 1 must be less than x minus 3, which must be less than 1. Now, let's see, can we get this particular inequality? Let's see, can we get it in the form of, let's see, can we get this in the form of x plus 3? Well, if we add, what would we need to add to x minus 3 to end up with x plus 3? We'd have to add a 6. So let's add 6 across here. So this implies that minus 1 plus 6 is less than x minus 3 plus 6, which is less than 1 plus 6, which implies that 5 is less than x plus 3, which is less than 7. So actually what we now know is that near a, that x plus 3 is actually bounded below by 5 and bounded above by 7. Okay? But which one of these numbers is it when x plus 3 is close to 5, or is it when x plus 3 is close to 7? Which one of those facts minimizes epsilon over x plus 3? Because we're looking for the smallest. Let's say we get the smallest, we really want to get the smallest delta. And to get the smallest delta relative to epsilon, we need to consider x plus 3, the absolute value of x plus 3. And you can see that if we have a choice, if we consider epsilon over 5 compared to epsilon over 7, well, epsilon over 7 has a delta value. So this is our, let's say, at this stage, this is two particular choices for delta. And you can see that epsilon over 7 is actually, epsilon is positive. So epsilon over 7 is actually a smaller number than epsilon over 5. So what we now have is from this particular restriction, we now have two choices for delta. We can either choose delta to be less than 1, that's the first case, or we can choose delta to be less than, in terms of epsilon over 7. So what we now have is we have two cases. We have two cases for delta, where the delta is an element of either 1 or epsilon over 7. So let's deal with the first case. So let's choose delta to be equal to, let's choose delta to be equal to 1. So what does that tell us? Here's another fact, is because delta, so let's choose delta, let's choose the minimum. The min, we really should say here. So let's choose the minimum between 1 and epsilon over 7. Let's say, for argument's sake, it's 1. Okay. So what does that mean? Well, then that means that 1 is less than epsilon over 7, which implies that 7 is less than epsilon. Let's just keep this fact now in mind, okay? Let's just keep this particular fact in mind. Okay? So now let's start our proof. So now what we have to do is, we found, by considering the conclusion, we found two possible values for delta. A delta that's very close to a, actually is less than 1, and a delta in terms of epsilon over 7. Okay, a delta in terms of epsilon, which is epsilon over 7. And the most appropriate delta to use would be the minimum of these particular two possibilities. Let's just argue, for argument's sake, let's say that 1 is the minimum. Let's see what we can derive from that. So now let's take the premise. So the premise says, so from the absolute value of x minus 3 being less than delta, in this case delta is equal to 1, we also have now that this implies that the absolute value of x minus 3 times the absolute value of x plus 3 must be less than 1 times the absolute value of x plus 3. Okay? Now, we already know that the absolute value of x plus 3, that the absolute value of x plus 3 is less than, we just figured that out a moment ago, it's less than 7, its upper bound is 7.